So the part for today that we're covering is we are going to be drawing the formation of the ionic bonds. So this, I kind of told you yesterday, this chapter is part 2, right? So we learned all the naming and formulas before break, and now we're going to take those formulas. We're now going to draw the picture or showing the actual bonding happening. So today, in my opinion, not too bad. Is we are showing the electron transfer. It just takes like a little more drawing, right? You have to just draw a bunch of things. But this is what we have already seen this example. This was part of our notes before break. And what it was helping us figure out is what an oxidation number meant, right? So everything's trying to get to that noble gas status. So when we have an ionic bond, we're actually going to have a metal give away its extra electron, or a cation give away an electron to an anion who needs it in order to move everybody to that full octet or your stable outer shell, right? So full valence shell. So we're kind of doing this. We're just going to have the right symbols used, okay? So that's kind of what we're doing today. So you are always starting with your your electron dot symbol, right? Your electron dot notation. So who remembers, how do I know how many symbols to put around something? So for example, we have lithium, I'm going to put 1 dot. Chlorine, I'm going to put 1, 2, 3, 4, 5, 6, 7. The valence electrons, exactly. So on our periodic tables that we have, they're usually indicated with that A, right? So group 1 is 1, 2 is 2, 13 is 3, 4, 5, 6, 7, and 8, right? So that's how many dots we're actually going to be putting on there. So what we have here, our formula told us that we were just drawing 1 lithium. I added the dot because it was in group 1. Chlorine, I drew only 1 of them. And then I went 1, 2, 3, 4, 5, 6, 7, because that's 7 valence electrons. At this point, what we're going to do is we're going to show the transfer now. So we see that lithium has an extra one. Chlorine needs 1. You want to have 8 all the way around, right? So lithium is going to transfer its electron to chlorine like that. So that's the during picture. The after, we're going to use brackets. So we're going to now draw lithium, what it looks like after. So it got rid of that extra electron on the outer shell. And it's now going to have that +1 oxidation number, right? Meaning it gave away 1 electron. Okay, and chlorine, we're going to go ahead and put all 8 around it. So 1, 2, 3, 4, 5, 6, 7, 8. So what that's showing you is chlorine now has all 8. We're going to put brackets around it because that's how you show an ion. We're going to put the brackets around it with the charge on the outside. So it gained 1 electron, meaning it has a -1 charge, which we already know oxidation numbers. Right? That's why I kind of had you guys do that part first. All right, and that's it. That's all you're going to be doing and showing this, okay? So let's run through oxygen and sodium combination, which was sodium oxide, okay? So looking at our formula right here, let's figure out how many we have to draw. How many sodiums do we have to draw? We have to draw 2, and we're getting that from that little subscript, okay? So we're going to have Na and Na. All right, sodium, we're going to look for it on the periodic table to figure out what group it was in. So sodium was in group 1, so therefore it's going to have 1 valence electron. So we're going to give each of them 1 valence electron, just like that. That's your Lewis dot structure. And then we're going to go ahead and have only 1 oxygen drawn. So oxygen is in group 16, so it has 6 valence electrons. 16, 6 valence electrons. So when you go to put the dots, make sure, kind of like the bunk bed rule. It is totally not related to the bunk bed rule, but it kind of works the same way, that you want to fill up each of the sides first with 1 electron, like spread them out first, and then start doubling them up. So if you notice, what I do is I kind of pick 4 sides around all of my symbols. I go 1, 2, 3, 4. Remember, we have to get to 6 for this one. And then I go back up 5 and 6. So I'm just kind of going around it. Okay, so this shows you 6. Now we're going to show the transfer with our arrows. So sodium has an extra one. This one needs one. So we're going to go ahead and draw an arrow like that. This one has an extra one. This one needs one. So we're going to draw an arrow just like that. So that's your during transfer. The after pictures, you'll have sodium without anything, except that it now has a +1 charge because it has given away 1 electron. And you have to draw the other one as well. And then oxygen is going to have 1, 2, 3, 4, 5, 6, 7, 8. After I just told you, make sure you go around like that. Obviously on the 8 ones, you already know they're all going to be paired up. And then we're going to put a -2 oxidation numbers because it gained 2 electrons. Okay? And I forgot to put it up here on this one. So let's go back up to this. What is the positive ion called? It's a cation. And then your negative one, anion. Right? So always your cations are the ones giving it away, and your anion is the one that is accepting, or ones that are accepting. Okay? Any questions so far? Let's try the next one. All right, so magnesium. So looking at our formula, how many magnesiums am I going to draw? I'm only going to draw 1. Look at the periodic table. How many dots does magnesium get? It's in group 2A, so it has 2 valence electrons. So we're going to go ahead and go 1, 2. So biggest mistake people make is they put them next to each other, like just they double them up right away. That's where I'm trying to tell you, make sure you spread them out. That shows you that you have single electrons that can actually get transferred, right? All right, and then fluorines, we need to draw 2 of them. So we're going to go ahead and draw 1, 2, and we're going to go ahead and give each of those fluorines how many valence electrons? 7. Good. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Once you have our Lewis dot diagrams drawn out for each element, you're going to go ahead and show that transfer. So this has 2 extra, so one of them can go to this fluorine, the other one can go to this fluorine. Our after picture will have magnesium with no more electrons around it, right? It's moved backwards on the periodic table, and it has a +2 charge, which we already found, right? Remember, you still, if you forget, like if you stop midway through your steps and you're like, what is the charge? Remember, you still have this little resource on the bottom corner of your page, right? So keep using it. That's always going to be the oxidation number. It shows how many of them got transferred, how many of it did it gain, right? So we're going to have magnesium with that, and then each of the fluorines are now going to have 8 around it with a -1 each. And then that's it. Give me 1 second.